This week's adventures in model making include some work on the canopies for Bexhill West in Coatbridge, this old book, some 3D printing and a diversion. So the headline news really is that I've bought myself a 3D printer. Now I've had some experience with 3D printing in the past, but thought it was about time I owned my own machine. And as they've fallen in price dramatically, and now what you get for your money represents tremendous value and the quality of the prints they produce, I thought, well, now's the time to have a go. Of course, I have a real need for a 3D printer. I've got various parts for Bexhill West and other projects going on at the moment for which a 3D printer would be really useful. So let's get into it and I'll show you what I've been working on. Now, when I unboxed my 3D printer, I set it up following the instructions they supplied, and they recommended a couple of test prints using some files they provided, which I think were for some chess pieces or something. However, I was keen to come up with something a little bit more worthwhile, and mindful that my goods shed needs filling up with some suitable bits and pieces, I drew up these. Now these are 17-gallon milk churns of this type that existed I think, the 1930s. Later ones had those sort of the more familiar parallel sides with the little rounded tops. Anyway, these things worked out fantastically and I'm really pleased with them. Just behind the milk churns you can see my second prints, the pedestal for the canopy column, and also there's a 3D printed moulding for the top of the column. Now I've conveniently mounted those two on the stick here, so this is how they came out of the 3D printer, and you could see the support material used to elevate them off the base just to get a nice crisp print at the bottom. Now these things are fantastic, although the profile of this isn't quite right. I need to change this. I sort of rushed it because I was keen to get something printed and see how it all look. Again, you can see I'm just using a cocktail skewer as the main post there. This will be replaced with a brass rod, with the idea that that will conduct electricity up to the lighting that will run the length of the canopy. However, for now, you get the idea. And in fact, these columns tapered slightly, so I will produce a moulding that will, or a printer, well, I don't know what you call it, a 3D print that will slide over the inner core to get the tapering up its length. But you see the principle of what's involved there. Now I'll put the drawing for the pedestal up on the screen and you'll be able to see that I've been able to incorporate the 1 degree slope that these platform canopies, that the platforms have. It's sloping back away from the rails. Now we discussed that in a past video, but that's all been incorporated into the prints and I'm delighted with how well they've turned out. All of which leads me on to the third of my printing endeavours, and this is the canopy column for Coatbridge Station, which we've discussed in the past. Now this one is tapered down its length, it's got an accurately profiled pedestal at the bottom. So let's spend a few moments discussing the work on this and where I've got with the canopy for Coatbridge. So I showed you in a previous episode how I researched this canopy structure at Coatbridge and how I found some accurate scale drawings of all the parts I needed. So I was able to use those drawings to extract the information for the individual elements, and I constructed two-dimensional profiles for all of the parts. What you see on the screen at the moment is my 3D model of all the parts that I've designed, and I like to put them into 3D and just check they all clip together properly and that the idea is going to work. In my hands here I have some of the component parts for the canopy at Coatbridge, and these have been designed that they will all clip together with various slots on the different components that enable them to push together something like that. Now I mention this because following my last video I had a really interesting question from one of the viewers, David Orff. And he asked what allowance do I leave when forming these joints? What he really wanted to know was what was the kerf, or kind of the saw cut's width, if you like, of the laser cutter. Obviously, when that laser beam cuts through the material, it deletes, for want of another word, a little piece of material. And so if we were making a slotted cut like this, we have to allow for that on both sides. If our allowance isn't enough, then the pieces will be too tight, they won't fit together. And if that allowance is too great, then the pieces are going to be sloppy. So I thought this is an ideal opportunity to have a look at that and discuss that in detail, because the answer to David's question, which essentially was, what is the width of the laser kerf, it's not necessarily as simple as it might sound. So we'll look at that in some depth. So then on the desk here I have the parts for Coatbridge Canopy, and hopefully you can see they go together, something like that, and when joined they create the lattice pattern of the ironwork on the station. And you can see here the slot, and you can see how that will clip together, something like that. Now, these components are cut from what is nominally 1mm thick material, and this bracket, this piece here, is 2mm thick. At least that's what the material is sold at, and this is where making allowances for these joints can be problematic. Because if I take my digital calipers and I measure this 1mm thick material, I don't know if you can see that on the camera, it's actually 1.24mm. Hang on, let's see if I can get an accurate measurement. 1.22, something like that. It's not 1mm. Similarly, if we look at the 2mm thick material, if we measure that, well, we can see it's a lot more accurate, 2.03, 0.03 of a millimetre greater. Now, typically, I would say, and I've measured this quite accurately, that the cut, or the kerf, the saw cut if you like, of the laser cutter, when it works, it leaves a gap of about 0.09 of a millimetre, just under 1/10 of a millimetre. Therefore, if I was trying to cut a slot such as this one, into which I wanted to take a 2mm piece of material, I would typically make that slot ever so slightly smaller, or probably by 0.2 of a millimetre. So I take 1/10 of a millimetre off of each side. So that slot, which you might expect to be 2 millimetres, I actually make 1.8. I hope that's not confusing. However, if we look at, let's take these truss pieces, for example. Now these trusses are cut from the 1mm thick material. Now these are failures, if you like, because I've made this slot exactly 1mm wide. Therefore, if we allow for the width of the cut, it's going to be slightly wider in reality. And I would expect these to pop straight in and be, if anything, a loose fit. And of course they don't fit. And that's because, once again, if we come back and we measure this material, it's too wide. So in this case, these parts just aren't going to fit. And this really is something that's worth bearing in mind, because, for example, these components were both cut from separate pieces of the same material, and this material, as we've just measured, is more or less 1.3mm, and this is 1.2. Now that 0.1 of a millimetre doesn't sound like very much, and indeed if we're working by hand we might be really pleased if we could achieve that sort of precision. But the danger is, when designing things like this, little kits of parts that you want to slot together beautifully, is that precision and that tolerance is so tight it can lead to all sorts of problems. So if I, to recap and to try and answer David's question, if I knew that this material was exactly 1mm thick, then I would probably allow for the cut, the slot here, to be exactly 1mm thick. knowing that by the time I've added the width of that laser curve of 0.1 of a millimetre to each side of this slot, I would then end up with a slot that would be 1.2 millimetres wide, which would mean these things would slot together easily, and there'd be a little bit of room there for the glue to help hold the thing together. Now, and I hope that hasn't confused you all, but there's one other thing we need to bear in mind, and that is that when the laser cuts, the cutting jet, for want of another word, tapers out slightly, and the thicker the material you cut through, the wider the kerf you will get. So typically I would allow for a kerf of 0.1 of a millimetre up to about 3 millimetres of thickness. Above 3 millimetres it could increase to 0.2, and if we get to, I don't know, maybe something like 12 millimetres thick, it might even be 0.3 or 0.4 of a millimetre. These are things that need to be borne in mind when you want to make something slot together accurately. David's second question, and really this one is probably of more use to the majority of the viewers of this channel. His question was what to do about the charring which occurs on the edges of the material when it's been laser cut. And it's a good question because it can be a really big problem, particularly if you're working with sort of timber-based materials, as the natural resins or synthetic resins in the case of this piece of MDF, they could tend to bubble to the surface and cause all sorts of problems with your paintwork. For example, if we look at this, we can see the white paintwork on this signal box structure. We can see the bleed through of these resins causing yellowy browny stains on the white paint, and this has been one of the greatest challenges I've faced with painting this stuff. But the solution seems to be quite straightforward. So the solution really is a threefold one. Firstly, if you're using MDF, which I predominantly do, there is a laser grade of MDF, a quality of material which tends to cut nicely. You get less charring on the edges and less of that resiny build-up. Now, laser grade MDF is sold by specialists as being a special thing, and it's a little bit more expensive, but it seems to me that that laser grade is actually a fairly common brand of MDF, which in the UK is sold with the name Medite. Now, I don't know if this is true or not, and I'm certainly not an expert, but it's my understanding that Medite is produced with a slightly more environmentally friendly resin, and it just so happens to cut cleaner. So whenever I buy MDF, I always try to buy Medite. Now, I struggle to buy the 1mm thick MDF, it's not very widely available, and I don't believe that is Medite, and I've found it doesn't cut as nicely. So for example, I will use almost exactly the same power and speed settings when cutting 1mm MDF as I would 2mm Medite. That in itself tells you that the laser's working harder cutting through the non-Medite stuff. So that's the first step, choose the right material. The second step, obviously, is a bit of sandpaper, and we can work on these edges and remove a lot of that charring, and that certainly works. But the third step is to how to get rid of the resiny deposits. Now, if you've got lots of finely engraved detail, it can be very difficult to sand that away and not remove the detail. So I use a paint product as a primer. Now, I can't remember how to say its name, so I'm going to put a picture on the screen here and you'll be able to see what it is. Now, this is a specialist primer that's sold for stopping damp in the walls of buildings and things like that. And I buy it, I think I get it from Screwfix. I'm sure it's available with the same product with different brand names and what have you. But I find the aerosol version of that product, although expensive, it works a treat. And as a little tip, if you're thinking of trying it, try and blow your coats on quite heavily. Now, typically when we spray paint something, we try and build our coats of paint up very slowly and very gently. But I found this stuff will atomise in the air and dry very quickly, and if you put a little dust coat on, you end up with that kind of sadly all too familiar sandpapery effect, and you wonder what's gone wrong. If you get the paint on fairly heavily, it will naturally soak into the absorbent MDF and dry with a really nice finish which retains all the surface detail, but it does seem to stop that resin bleed through. Being as it's a white primer, it's an ideal base coat for sort of any other colour you put on top of it. It makes your greens look a little bit nicer, and certainly you can get white on top of that white primer, and I don't tend to see the bleed through anymore of the yellowy resins through the paintwork. So if you're having that problem with your MDF structures as you're painting them, I can't recommend that product enough. As I say, it's expensive, but it's really good. I'll try and leave a link to it actually on the Screwfix site down below, and you can go and have a look and see if it's see if you can find out a bit more about it. And it may be you can find an alternative product that does the job just as well. I have tried in the past all sorts of things like MDF sealer and stuff like that, and these products do work. They're okay, but just the products I've just mentioned I think is the best. At the start of the video I showed this book, and it's really brilliant. Now let me explain why I've got the book. You see, a couple of episodes back I showed my Goodshed model, and I showed 3 pieces of rolling stock that I'd bought that I was very excited about. And somebody sent me an email and said, well, shouldn't you be designing your own? Wouldn't that be a fun thing to have a go at? Now I think it was slightly tongue-in-cheek, but it got me thinking, and it made me think, well, I haven't got any drawings of wagons and stuff, and really that was beyond the scope of what I thought this channel which was going to be about. I thought this channel would be about architectural model making, not necessarily just railway modelling, and to start designing wagons and things I thought would be taking me down a road that I was unfamiliar with. However, it sort of sowed the seed of an idea, and so I bought this book of historic wagon drawings. I'm sure many of you will have seen this and have read it yourselves. And I bought this thinking this might be a good starting point for some of my own work with designing some rolling stock, particularly as I knew I was going to be getting a 3D printer. Now, whilst I'd been waiting for my book to arrive in the post, I looked online and I found a wonderful set of drawings for, these are railway clearinghouse drawings for a 12-ton wagon chassis. Now this set of drawings has everything you'd need to know. In fact, there's drawings for every single component. You could build one of these from scratch just using these drawings. So of course that whetted my appetite, and it wasn't long before I'd scaled the drawing, popped it into CAD and started generating a profile for the chassis, which I thought I would 3D print. And this is what I came up with. This is the underframe for a steel framed wagon, and the drawing is pretty good, it's fairly accurate, and I'd thought to include the holes for the coupling pins, and I thought that I might want to actually make those sprung, so I've continued the holes all the way through, and the same with the holes where the buffers will go. I thought if I continued those right through the structure of the chassis, I could possibly extend them and include springs and things inside here. So that's what I had to go at. Now, it wasn't long, I sent this to the 3D printer, printed it out, but I ran into some issues. The flange thickness on the channel section that is used for the side frames, at a scale thickness it was just too thin, and I got some warping, and I was a little bit unimpressed, to be honest with you, with the quality of the prints. Now, probably what I should have done is spend a bit of time reading the printer instruction book and maybe change some settings, but not wanting to be held back and wanting to have something physical to play with, I thought I'd set about having a go at the timber framed version of the same wagon, because the timber members are a little bit bigger and I thought they'd be less likely to warp. And so I have here the 3D printed version of the wagon chassis. Now I hope you could see it's quite finely moulded. I was particularly pleased, I don't know if the camera will pick this up, with the coupling hook. I was able to get the profile of that just perfectly spot on, and I don't know if I can get this camera to focus. There we go. It worked out quite nicely. Now these, I think they're called W-irons, these bits that the axle boxes fit on, I made those slightly overscaled just because I wanted them to have some thickness so that they'd be quite robust. However, I was quite pleased with this as a first print. Something to bear in mind, and again I hope the camera will pick up on this, is where the support material was added, it left some sort of unsightly marks which I wasn't too impressed with. However, I was encouraged enough to have a second go. So I was able to use the drawings and reasonably accurately produce the buffer stocks. There's the coupling hook, and I also included, because I thought it would be fun, some of the bolts that would hold the W-irons on. Now I'm feeling a bit bad here because I didn't put the washers in, and to be honest with you I didn't think these would print out, so I thought, well, I won't waste too much time with it. And this was the Mark II version, still with its support. And you'll see that in this case again, I don't know if the camera will focus on this. I've got a new camera, please bear with me. I thought I'd have a go at the axle boxes. And this really is where I've become quite excited, because the axle boxes fit. In fact, the quality of the fit is superb. They fit, hang on, a bit fiddly, there we go. They fit in the W-irons, and this is difficult for me to show you, but they slide beautifully. So this has got me thinking about working suspension. So among my collection of random bits and bobs, I have an old bogie here. It says Bachmann on it. I'm not sure what it's from, and I think this wheel isn't actually to scale. It's the wrong size. However, I wondered if it would fit, and sure enough, this is going to be fiddly, so please bear with me. It is possible to fit that wheel into the axle boxes, which have an axle hole, and there we have it. So we've got an underframe with an articulating wheel set. Now these axle boxes, again I rushed these, I just wanted to get something done. They are more or less correct looking face on, but they're slightly too deep from the side. However, that's all fixable. And so we come back to this book I bought of historic wagon drawings. Having produced the print, I thought I'd see if I could find an image within it of what I'd just 3D printed. And sure enough, 12-ton fitted drop side wagon. And I found that if I laid my 3D print on top of the drawing, it's pretty spot on. So I was delighted with that. I thought that's worked out a treat. So of course that got me to thinking about other drawings that might be in this book. Now, continuing this diversion into things about which I know absolutely nothing, I found in a second-hand shop recently this horse box, and it said Southern on it, and I thought, oh well, that's gonna do the job. Because you see, at Bexhill West there was a loading platform where I know every year horses were unloaded for the local horse show, which I think back in the day was quite a big event. So I saw this in a second-hand shop window for, I think I paid £3 for it, and I thought, well, that'll do. But I got to looking at it, and I thought there were certain things about it which I just didn't like. I didn't like the fact that brake shoes hang in mid-air and they're absolutely nowhere near the wheels at all. However, I thought, would there be a picture of this in the book? And sure enough, I found one. So this here is listed as a Great Western Railway horse box, and I'm pretty certain it's exactly the same sort of thing as what we've got here, except I noticed the vacuum cylinder for the braking is in the wrong place. But it got me thinking, is this the right thing? Is it in the wrong region? I don't know anything about any of this. So if anybody's watching this and you know a little bit about horse boxes and the type of horse box that might have delivered horses to Bexhill West at any point in time, really, from the early 1900s till when it was closed, I'd be delighted to know, because I'd like to have a go at recreating one of these as a 3D print. And there you have it. That's been the sort of the overview of what I've been up to this week. Certainly I've found my experience with the 3D printer thus far really very eye-opening, and I hope to take the design of that wagon a little bit further. I'm confident that we can have springing incorporated into that, sprung buffers, and certainly a sprung draw gear. I think that would be really nice. I don't know if this is commonplace or not, so if you know of anybody else who's doing something similar, then leave a comment down below and let me know where I might be able to maybe find some of their videos or some of the stuff they've been working on the internet, because I'd be really interested to learn some more myself. And finally, thank you so much for all the subscribers who've come on board in the last week. We're now over 250, which is just amazing. I'm really very grateful. So thank you very much indeed. And until next time, bye-bye everyone.